Greetings, welcomeness of amigos. Mr. Waddy here. We're taking a look at 7.2. We were multiplying polynomials, primarily using the distributive property, and then we also learned like a little trick called FOIL, which is really the same thing as distribution, but it works when you're multiplying a binomial times a binomial. And so here's the homework from last night. Going to show you a few of the problems here. And for distributing, here we go. So the first thing I'm going to do, I'm multiplying this two-termed expression by this two-termed expression. I know it's multiplication because there's an implied multiplication dot right in between those parentheses. And I'm going to distribute both of the terms, or in some cases, all of the terms from the first set into the second set. So I'm going to take this z, and I'm going to distribute it to both of those, or however many terms this set of parentheses would have. And so I've got z times z is z squared, and z times 3 is 3z. Easy like Sunday morning. And now I've got to distribute this -5, right? So that's, yeah, -5z. Agreed. And now we should go through and combine like terms if we've got any, right? You have the equation. Well, walk us through it. Does z squared have any one to combine? Yeah. Yep. Let's see. And yeah. Whoop. And so there we go. I'm left with a second degree, or quadratic is the other name for it, and 3 terms is a trinomial. And one of the things they wanted us to notice, which I think you can do this without noticing this, is you could have realized that multiplying polynomials gives you more polynomials. That's the idea. So, all right, I'm going to walk through this next one quicker because I want to get to some more interesting problems. So let's see. 3m times m is 3m squared. 3m times 9 is 27m. Let's see, multiplying by 1. I could multiply by 1 in my sleep. Let's see, plus 1m, and multiply by 1 is plus 9. And I'm just going to jump right to writing this answer, so that's going to be 3m squared. 27m plus 1m. Yeah, yum. And then plus 9. So there we go. So that's our answer there. Let's see. Let's look at another one. How about using the FOIL method? FOIL method. So, well, we gotta use both. They're both actually doing exactly the same thing. Where's my scroller here? Right. This one is doing the distribution with the arrows. And FOIL is actually going to give you the same thing. FOIL stands for firsts, right? Outer. And last. Yes, I agree. I forget what color pattern I used the other day, but the first terms would be w times w squared is w cubed. Here, Austin, if you could stop the tapping. And when I do the w times w squared, I add the exponents. The invisible 1 plus 2 became 3. Let's see. Outer would be the outermost terms. So notice the outer terms for these two parentheses would be the w and the 3w. No, I'm multiplying, though. 3w squared, right? There's a little invisible exponent of 1 plus 1 is 2. All right, inner, so that'll be the inside most terms. Yeah, agreed. And then the last terms for each of these parentheses. So 5 times 3w is 15 w's. 15 w's. And then I combined w cubed, had no terms to combine. 3w squared plus 5w squared is 8w squared, because those were like terms. Yeah, and we're done. That W was a little too many W's. That was a triple W. There we go. All right, so that's the FOIL method. FOIL method only works for binomial times binomial, so beware, my friends. Beware. Oh, I like this. I like it a lot. Let's see. I'm going to think about this in two ways. I'm going to think of the area of this big square. What's the area of a square formula, by the way? That would be volume of a rectangular prism. Yeah, length times width. So I'll do x plus 1 times x plus 1. And then I'll end up finding the area of this little rectangle. Right, so the area of that will end up being, right, the 5 times x minus 7. And then I'm going to subtract those two areas. So let me do some distributing. X squared plus x, right. And then plus x and plus 1. So my big area is going to equal x squared plus 2x plus 1. And notice this is just single distribution. Remember back in the day when it was just plain old single distribution? So 5x minus 35 will be the area of that little rectangle. And so the area of the shaded region, I'll shade it in like this, I guess. What? Is going to use a property or a principle, a postulate called the area addition postulate. Yeah. So the blue area is going to equal x squared plus 2x plus 1, and then I'm going to subtract this, and I've got to be careful subtracting that so that I make sure I'm subtracting both of its pieces. So you could write this first one in parentheses as well, but that's not as necessary. But I guess we did see some of those like that earlier. And so this is a callback to 7.1. And let's see, subtraction I can change to addition as long as I opposite the signs of each term on the inside. So this 5x is now a negative 5x, and this negative 35 will be now a plus 35. So let's combine. X squared has no like terms. 2x can combine with a negative 5x, so that's negative 3x. And then lastly, we'll have the 1 and the 35 is equal to 36. And so that will be the area, or a formula that represents the area of just the blue as I have indicated. Okay? So, right, length times width, and then I had to do some foiling is what I had. I think, did I pick one more question? I did! Oh yeah! Here we go. So this is a binomial times a trinomial. So FOIL will not work, my friends. So I'm going to have to either double distribute or triple distribute, whatever you'd want to call it. So f times f squared is f cubed. F times 4f is 4f squared. And f times 8 is 8f. But I've also got to distribute that plus 1. I'll do that on the downside, the down low. 1 times f squared is plus f squared. 1 times 4f is plus 4f. And 1 times 8 is plus 8. And so now as I go through and combine like terms, notice f cubed. There were no other cubed terms to combine it with. 4f squared plus 1f squared. Remember, there's an invisible 1 coefficient there, so that's 5f squareds. And let's see, 8f plus 4f. Yeah. 12 f's. And then the plus 8 just hanging out, feeling great. Let's see. I guess I'll just write the plus 8 like that. And so that would be my final answer. All right? Thanks for watching, internet friends. Bye-bye.